Hello and welcome to One Tech World. Just to give you my introduction to begin with, I solve business problems using technology, data, and AI. Overall, I have 18 plus years of experience in the tech field, and I had many roles such as data analyst, product manager, program manager, product leader, strategy consultant. I had my own startup too for 2.5 years. And geographically, I've worked in many continents, just to name a few, like Germany, Spain, UK, India, Malaysia, Japan. But I guess I'm settling on UK. I also happen to uh, be a winner of Women in Tech 100 2024. These days, I try to write, and mostly I write on data and AI. Looking forward to show you where are we heading in the world of AI. Today, the topic that we are covering is depleting Earth, AI and the cost of creating intelligence. What nobody is talking about. We are sitting at an inflection point of for human civilization. I'll explain you what it means for all of us. Just to make give you perspective, I divided this presentation into three broad categories where I will explain you why in terms of AI, I'm talking about human civilization because I call it that AI is a hockey stick of human evolution. What is the appetite of AI and what are the civilization crossroads? It's not just any technology we are talking about here. It will change the world for humans as we know it. Just to give you a perspective, what we are talking about. Almost most of the scientists have consensus that we somehow figured out the fire almost 1 million year ago, but it took us several thousand years to reach to a point to when we call agriculture revolution, which was estimated based on anthropology how they trace the origin of agriculture revolution. It's around about average 10,000 years ago. From 10,000 years ago, all the civilization that we know of, we read as mythological or the real civilizations. It was just 250 years ago when we reached to a level where it was industrial revolution. We had railroads, we have steam, we have fossil fuels, we were having manufacturing. There were so many things that changed for us. But from those 250 years, it took us just like 180 years to reach to age where we can call it internet, and that's when everything changed for us. Now we call it data as resource. We are sitting in a global digital economy. We are globally connected. We can fly anywhere. We can see what is happening in US. We have what is happening in Japan. So thanks to the internet, we have social media. Everybody is glued to the phone. We are globally connected. But that's when the real fun started. That is where the hockey stick happens. And this is where we are sitting. When you say you are here, we are sitting between 2025 to 2030. It is an exponential growth. If you go back, fire was the original hockey stick. It changed everything for us. And now, but thanks to that hockey stick, it was flat for millions of years. Then I will call the blade that changed everything. AI is a blade of blade. Just to give a perspective that what is the AI appetite? Everybody is talking about that. the digital transformation is happening through AI. We have so many tech companies. You keep hearing about ChatGPT, you keep hearing about Claude is doing this. People are losing jobs, people are getting replaced by AI. There is so much of fear mongering which is happening. All the talks that you keep hearing about, but what you don't hear about, the AI energy's appetite. And I thought, considering the time that we have, I'll just show you the numbers. If you think about just in 2024, in order to run the huge data centers, which is the backbone of AI, electricity it guzzled. If just to give you further perspective, it will consume by 2030 the electricity as equivalent to the entire population of Japan. US electricity already going to data centers. It is just rising and rising. It is 2% up from 2017. And if I show you the numbers, the next slide, you will see the real change that happened after ChatGPT. 30% is the annual growth of AI server electricity. Can you imagine? This is a huge number, 30%. And look at the graph that I am showing you. In 2020, we had just 260 terawatt per hour, just 260. From 2020 to 2030, in just 10 years, this is the amount of energy it will require. If I move on to the next slide, this is what we are talking about, just to give you another perspective. A single large data center consumes as much as water as city of 50,000 people. Google's total water consumption across all data centers in 2025 alone was 6 billion plus gallons. Direct water consumed by US data centers in 2025, 765 billion gallons. And if you look at the number, 870%, I can't just imagine my eyes. This is the increase we are talking about only next 3 years. It is an impossible trade-off. These data centers needs a super clean water. As humans, you buy distilled water or maybe have your own distilled machine. These data centers, to keep them cool, they need a further next level of clean water. So as humans, we can't use salty water from the sea, which is plenty. The same goes with these data centers. In order to keep them cool, you need the same grade water as humans is consuming, even a better grade than that. Now, if we are talking about AI chips appetite, these LLM models, large language models, they are not running on their own. The speed that they are running is huge. Imagine the market that we have. It's $52 billion market in 2025, 165 billion by 2030. Look at the change within 5 years. And in that, GPU, which is which started just to process the images of our gaming machines, how you play your games. They just want they started, Nvidia just started using these specialized chips to actually run those simulations faster. But now AI has found a new use case through GPUs. It gives them huge capacity. So look at the GPU share, 46.5%. So when you say TPUs are specialized tensor processing units, are from Google. It's a proprietary, only select companies, the top tech companies are using it other than the Google. But this is where we are. And another, which is the underdog, very few people talk. It's ASIC. That is also a kind of a processing unit that AI needs. So this is what we're talking about. NVIDIA, 4 million plus GPUs. Google, 2.5 million TPUs. Amazon, 1 million Trainium 3. So that is their in-house processing unit chip. AMD and others, they mostly use ASICs. Amazon also use ASIC. But this is what actually we are talking about. And now, which very loosely talked about, only few circles know that actually how much are the minerals that we're using in order to build AI. And the top three minerals. Otherwise, we have so many, but these are the three top minerals that we require in order to build these AI machines for us. Majority is the copper. Look at the change. In 2020, we were just talking about a little and no less use of copper worldwide. Now, look at where it reached. It's almost at 512 ton by 2030. The huge, so you must be thinking, where does go in AI infrastructure? So they go in AI chips, they go in data center, they go in energy grid, which we talked about, they go into cooling systems. So if you just look at this table, it's 5 million gallons water per day plus mineral intensive cooling. So all of this data that you show, and when you look at that, the amount that in last 5 years itself have been used in terms of electricity, in terms of water, in terms of minerals, and these top three companies are the major contributor to it: US, China, and Europe. So there are other companies as well, Japan, in Taiwan, but they were doing it all along. So they still have a very less use. They have so many fabs before, but now the level has gone through the roof. If I just have to sum up, it's almost 650 billion bet. Most of you must be hearing about the AI bubble. This is what we're talking about, 650 billion. And that 650 billion just alone by Amazon, Alphabet, Microsoft, and Meta. And if you see from 2025 to 2026, look at the exponential change. Everything is almost double. The combined capex that these four companies have to build is 650 billion. And on an average, it's a 60% jump from 2025. AI capex now equals 0.8% of US GDP. It just humongous. Last year, there was so much of uproar about, okay, AI bubble is happening. But this year, when the Google quarterly results have released and the question have been asked from a Sundar Pichai, who is a CEO of Alphabet, a parent company of Google. Somebody asked what keeps him up at night. He said, these are his words: compute capacity, power, land, supply chain constraint. How do you ramp up to meet this extraordinary demand? And I would say extraordinary is also a very uh, underrated word. It's like impossible demand. Now, I leave you with these things. Case for AI. When we are talking about AI, is AI could offset its own emission if adoption is widespread. What we are talking about, just on the positive side, AI driven drug discovery, climate modeling, material science breakthrough. We can do so many things with it. Fast mover nations gain economic and state strategic advantage. That's why this humongous scale. Because right now, China and US, they are competing with each other. It's like just the same, like what they did with Russians. US and Russia, they were fighting for who would reach the space first. AI optimizing energy grids, but it's just 15 to 20%, but it's still huge. Efficiency gains. There is a Chinese model which actually showed a different model which can actually offset most of the capex cost. And very importantly, slowing down. If we are talking about we need to slow down, it doesn't help anyone. So we need to figure out how can we slow down, because the scale that we are reaching now, I'm not sure where it will go. But at the same time, Gartner projects 80 billion in contract center labor savings by 2026. We are talking about this year alone. We are saving 80 billion. Although it looks a huge number, but on the downside, why not AI? Data centers are one of the few sectors where emissions are growing. And it's not growing, they are exponentially growing. Water scarcity. 25% of data centers face worsening drought by 2020. And mind you, across the world, including my own home country, the data centers are coming up in the states where water is already scarce. And societal disruption, mass displacement of jobs. If you are gaining 80 billion in contact center labor savings, imagine the other numbers in other sectors. Critical mineral supply chains. In this race, we are losing our critical mineral supplies. And I'm not sure demand will meet the supply. And most importantly, AGI safety concerns. Creating intelligence without alignment. If you are racing towards first mover gain and you are not bothered about the safety concern, something or other will happen. Hope that's not a catastrophe. Electricity bills. If the AI is using so much of electricity, who will end up paying the bill? We, humans. Our electricity bills will shoot up through the roof. And natural living disruption. Nobody even talks about it. When you're setting up the data centers, you're using so much of water, you're using much of critical minerals in such a space. You will disrupt the natural living order. This is not a binary choice. The question is at what pace and what guardrails and for whose benefit. This is actually not a technology question. This is a civilization question. The companies, governments, and individual who act now with both ambition and responsibility will define the next chapter of human evolution. Whether AI becomes a fire or a flood depends on the choices we make in this decade. Thank you so much.